And let's see. Let's try doing round F this today. Today I only have 1 hour, so I hope to solve maybe the first two problems, if possible. The first three. Let's just see how much I can do. Kickstarter round G. The last time round I got stumped at the lock problem. Yeah, it was kind of weird because like you couldn't do a brute force. You had to do some sort of like mathematical way to ensure the minimum number of turns needed for the lock. But it's okay. Today we will do round F. Um, Doing the mainly the easier problems right now because I'm still learning how to solve the harder ones. But definitely one day when I'm better, I will stream how to solve the harder problems, like the last problem of the kickstart round. That could be a 1 hour stream to just show you all how to solve it. Yeah, but they always say that you have to start somewhere. Let me just check my Twitch. Okay, yes, my Twitch is look at that inception. Okay, so this is the problem right now. Let me just delete away. So if you are interested to do Google Kickstart, I recommend having a format like this. You have a input and output over here. Okay, am I streaming? Yep, I'm streaming. Yep, and then over here, this is the um, you have different case numbers, and then over here in your solve, then you will do the you do the code to solve it. Okay, so now there are n people numbered from 1 to n standing in a queue to withdraw money from an ATM. The queue is formed in ascending order of their number. If person numbered I wants to withdraw amount AI, maximum amount they can withdraw is X. If they need more money than X, they need to go stand at the end. What a lousy system. If they need money more than X, they need to stand again and wait for a turn. Alright. You need to find the order in which all people leave the queue. This seems like a simulation problem. Okay. The first line gives two space separate integers. Okay, so we have n, AI, and x. Oh, it goes until 10 to the power of 9. Hmm, okay. And what's n? N is the number of people in the queue. So over here, 2, 3, 3. 3, 3 is the... Okay, so let's see. The input for this is n and x. Okay, so let me just do long nx. Okay, let me take in this. For long I equals 0, I smaller than n, I plus plus, and then we take in the next one. So basically I can actually do a list, I guess, because vector, if I were to push out one by one, it will take very long to do this. Hmm. No, I'm just thinking whether I want to use a vector. Still think it's possible to use a vector. Let's see the runtime. Stand about 5, and then I can keep going through this 10 to the power of 5 up to possibly 10 to the power of 9 times. So that's 10 to the power of 14 times. I think a queue data structure would be good. Then I can even have the last structure here. So the order of the queue can be also an input to the queue itself. So let's see. Yeah, this is quite kind of challenging. I'm not too used to doing queues, but I guess this would be helpful in terms of practicing how to use queues. Okay, queues. I mean, I could use an array as well, I guess. I don't really need a queue for this. I guess it's just push back. Yeah, standard is push back, push back. Let's just try doing like the brainless method first. So we do a queue. Okay, how do we initialize a queue? Constructor. I like C++ because of all the available constructors you can use to solve your problem. So we can just take this. Can't remember what's the DQ already, but their example they give. Yeah, let's just search what a DQ is. I'm kind of curious what it is over here. Oh, double-ended queue. Okay. Why is my internet so slow today? So if it's a DQ, you can do front and back. Oh, nice. You can push back and push front, pop back and pop front. So there's a doubly double link list, I believe. Yeah. If not queue, you can only access it once. It's okay. I don't really need a DQ for this problem. I just need to push the thing in one way. So I guess I'll do a queue people. Let's just call them people. Okay. And this one will be a long. Okay. So actually, this should be a queue long people. Okay. People dot push back. C in amount. Okay. So I have an amount here. So over here, actually, I should do uh, a pair here. Okay. Because we want the index also. Yeah, so only when the amount is less than zero, then we pop it to the. So we have another thing called final order. It's called prints out the people in order. So let's see, iterate over q c plus plus. Yeah, so let's just do the output processing first. This problem is good. It makes me practice the q data structure. Yeah, it's like that. Yeah, actually, if we had this, like, we can even print it out like that. But no, let's not do this. We just do final order dot begin. See out. Over here we can see out the uh, we dereference the, and then okay. So if is not the end. So I cannot do a -1 over here. So it's kind of tough here to not print out the space. So there will be a space because I can just bypass it because you see we have a space here for case one. Yeah, what I can do is I can remove this space here. Okay, and then I can just print out like like that. Then I can not bother about when it ends. Uh, at the end of it, I'll just, yeah, see, I'll end out here. Okay, so this is This is basically to take in the inputs. Can you see my screen, by the way? Let me just check my screen. Yeah, you can put in the comments, because I have a phone here. If you cannot see my screen or anything, you just let me know. Yeah, if not, we'll just try to solve this. Okay, so this is to print out this, the order of people. So right now we need to do a code to simulate the queue. So okay, while people dot size greater than 0, that means while there's still people. Okay, then I guess we need to, you know, we need to pop one by one, and then when we pop one by one in the queue, I believe is a queue is a first in first out system, so the first person will come in. So after we pop the queue, and then we see whether the person is it. Okay, so let's just let's do this. Okay, so pop, we need to pop the queue first. Okay, so I'm just thinking, if I pop my queue, can I get, is a void. So I remember, if I remember correctly, you will need to, oh, something's wrong with my internet. If I'm not wrong, because when you pop your queue, you cannot take the data that comes out. So you need to actually store it in the data by reading the front of the queue first before we pop the queue. So let's just do this. Okay, so actually I can just do an auto, right? Yeah, I don't need to define pair. Yeah, so auto, uh, let's just call it person. Okay, because we call it people, so maybe the first one equals to people dot fronts. Yeah, we just take out the first person. So let's just check whether is taking the people out in the right order. We just print out the person dot first, person dot second. This is just to check. Yeah, I just want to make sure that I got it right. Then after that, people dot pop. So if this is done correctly, it should print out one by one. Okay, auto is okay. This one is okay. This warning. So error, no member name begin. There's no begin in the queue. There should be. I mean, a queue definitely has a begin and an end, because it's a structure. You see. Oh, unless this is iterable queue. Yeah, looks like I cannot do the iteration like that. I might have to pop. I might have to pop one by one. So yeah, yeah. Maybe I'll just use a vector for this. Yeah, so that I can iterate over it. I mean, here I want to use a queue, because when I do my deletion of the person, I don't want to take O n time, where n is the number of people. I don't want to transfer my number of people from the back of the array to the front of the array again. So I just want it to be like a linked list. You delete. Oh, hi Rachel. Sorry, I just saw your chats. Print hello world. Yeah, no, because when I do like this Google Kickstart thing, I cannot really. You see, let's say if I go back to my screen with the comments, because I'm using my laptop here. So you see, if I were to use this, the comments are all here. Can you see the comments? Yeah, the comments are all here, because I'm using Twitch, the stream service. What do you call that? Twitch Studio. Yes. Yeah. So Yeah, I'm actually viewing my the comments on my phone. Yeah, until I get a better stream device. I noticed that you all use headphones and everything. Yeah, I do have like my headphones as well, but not really needed because there's no sound coming out from the computer program. Yeah. Oh yeah, Pangala, are you also Rachel's friend? Because I'm not too sure. Like, have I met you in real life before? Okay. While you answer, let me just. Oh, we have met. Oh, what's your real name if you don't mind? Yeah, so that I can roughly know. Oh, okay, okay. We probably met at Sky's wedding. Oh, Xiang. I see, I see. Oh, I didn't know you were on Twitch also, but I suppose you would be because you are quite sociable. So I probably think that you do you stream as well? Because I know Rachel recently started streaming. Yeah, so I'm not sure whether you also do streaming. Oh, thank you, thank you. Yeah, I think you might find today's stream quite boring because this is like solving some programming puzzle. You can think of it like puzzle solving. Yeah. So yeah. Yeah. Anyway, let me try to solve this first. Yeah. So I do have to like look through my inputs for the order. So if let's say I use this final order as a vector, I can then iterate through because the Q function for C++ doesn't allow iteration. Yeah. Oh, Joshua is fine. Yeah. I've been taking care of him the whole day. Yeah, so now it's like my short 1 hour break before dinner. Supposed to stream from 4 to 6, but my wife had some like meeting, so I had to stream a bit later. Yeah, but it's okay. I mean, I just make do with whatever time I have. Yeah, life as a parent, especially when the kid is not going to childcare yet, it can be quite busy because it really depends on on the needs of the kid. Yeah, you'll probably understand next time when you have a kid. Yeah. But it's okay. It's okay. I think it's still alright. It's not to say that I cannot do my own stuff when taking care of him. It's just that when I do take care of him, um, I have to like I can't do like long programming because I need to like concentrate to do programming. I cannot like do 5 minutes programming then come back again 5 minutes later. I will lose my train of thought. So I read books instead. Yeah. So those books I can read halfway, then I can come back again. Yeah, then for longer time slots like this, then I go back to streaming. Yeah, I'm still trying to finish my games though. Yeah, I have some Unity games that I want to create. Yeah, so I'm just looking for time to finish it. Yeah, nowadays I stream my games, my game creation. So it's like two in one. So it's better. The one you posted on Facebook, then you mean the one I post on that was quite some time ago. The one I post on Facebook was the card game, right? The attack or defend one. Yeah, that one is done. So I mean, if you look here, yeah, this is my list of games. Yeah, so this attack or defend, this is done already. Yeah, I spent about 1 month coding this game. Yeah, so that is a pretty hard game. It's it's from only two people have completed it. Yeah, 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 yeah. So yeah, I actually kind of like it. Oh shit, I revealed the secret. So for the viewers here, you can see that actually this asteroid is a secret. Yeah. So by right, there's only 9 planets, but then I decided to make a super big bad boss. So the asteroid is like 3 times more difficult than the hard mode. Yeah. So if you complete like hard mode, like Neptune is hard mode. Yeah. If you complete hard mode, you realize that hard mode is difficult but not that difficult because this guy here in asteroid, I really just basically I programmed the AI. So this AI is probably quite intense. Yeah. So far, only got two people who can complete everything. Yeah. So I mean, if you are trying the game, you let me know. Yeah, I I kind of like this like views this viewing here. So it took me like about 2 3 days to get this configuration out. And you see the back, the galaxy is moving. Yeah, kind of like it. Yeah, I like the atmosphere. Yeah, so yeah. Now I'm doing another game called Four Buttons. So it's like, yeah, literally four buttons. Sean's Adventure. Yeah, Sean's Adventure is quite fun actually. Yeah, I digress a bit. Let me just show you. Let me just show you this. Yeah, since you asked. Yeah, I digress a little bit. Yeah. So Sean's Adventure is my first platformer game I created. Yeah. So you can like double jump. Yeah. Actually, I like this kind of platformer a lot. Yeah. Yeah. So some people tell me that the last part, oh, it's a bit loud. The gravity is a bit like the gravity is kind of insane for this game. Yeah. Oh crap. Yeah. Let's just play until I lose all 3 lives, which is quite easy to lose. Because yeah. Oh, that was so close. That was so close. Yeah. I should probably stream myself playing all the levels for this, because actually there's a lot of shortcuts and hidden passages in this game, which you probably wouldn't know unless you created it. Like this is one shortcut. So this shortcut allows you to skip the jump quest at the top. You can just go by this long ladder at the top, and you can I probably should stream this like on a separate occasion, uh, because there's quite a lot of secrets in my game that I don't think you would know unless you try it. Okay, so I'm a bit lazy to play this, so I just activate cheat code. Yeah, so in the in the later modes of this game, there's two powers that you can use. One is called anti-gravity, and the second power is called what I forgot what's the second. Yes, you can teleport also. Yeah, so you can teleport and you can use anti-gravity. So the stages are harder actually in the later half of the game. Yeah, so this is like the easy mode of my game. Later there's a harder mode. How long? It took me about 2 weeks to create this. Yeah, but I did it as part of a course. So I'm a bit lazy to play this in the proper way. So yeah, pretty fast. Yeah, I almost died here. I'm just cheating. Graphics is just a rip-off. Yeah, I didn't create them. I just took some free assets. Yeah, I'm just a bit lazy to play my game, so I just use my cheat codes to complete the level. So if you complete this place, you have this extreme mode that you can go upside down and you can teleport. So it becomes harder and harder. Yeah. Anyway, I think I can complete this entire game in like 10 minutes. So let me just finish this. Sheshan, do you manage to complete this this game? Yeah. So this is like how. So there's a cheat code here. You can go up. Oh crap. Okay, this wasn't planned for. I don't know how this went to. Okay, I better fix this part here. You are not supposed to be able to teleport out of the screen like that. So this is a bad demonstration. Yeah, I found a bug in my own game. All right. Anyway, yep. So since this happened, yeah, if you are interested, yeah, I can stream this even the extreme levels another time. I don't have it on mobile. It's a purely computer game, so I can give you the link. You can just come to this page. You can see over here. There's this Actor of Defense Breakbuster. Breakbuster is one of my most popular games. It's like you have to break two bricks of the same color or more, and this is the Sean's Adventure. I have another game called Tic Tac Toe, which is not here because it's still under development. Yeah, but yeah, let me just put the link here if you are interested to play it. Yeah. Okay, I should at least solve the first question of Kickstart today. Yeah. Okay. Let's try to finish this. Okay. So we simulate the queue. We have a person at the front. All right. Okay. So I just want to see whether this is done properly. Let's just play this. Okay. So no member called N in queue. Okay. It's no longer a queue anymore. It's a vector now. So I'm not sure why it's still. Oh, I didn't save the code. No wonder. I need to save it and run. Okay. Three errors generated. Person dot second, person dot first is not a structure. No member got pushback in queue long long. No member got pushback. This is not possible. There's a pushback definitely in a queue in the queue type. There's a push. Oh, it's called push. Okay, it's called push. It's not pushback. Pushback is for vectors. Okay, so you see a lot of problems for the code. I'm not very familiar with queues in C++. I'm more familiar with vectors and arrays. Yeah. Error member reference base type long long is not a structure. Okay, so what's the error again? The error is this make pair here. It's not. Yeah. I guess I cannot exactly, you know, make. Okay, so the problem is here. The queue structure is long long, but over here it should be pair long 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 long. Okay, this is a bit confusing, but this means that the queue is of a queue of pairs, and then that should work now. Okay, let's try again. Try running the code again. Okay, now it's working. So let me just copy and paste this thing here. Okay, command not found. All right, let's try again. Two. Okay, case 133 274. Okay, so it should print out. Uh, number one person is two. Number two person is seven. Number three person is four, and that's correct. All right. Then maybe what I want to do is I want to push in the order here. So okay, so this take in the inputs. So when we simulate the queue here, okay, so this part is correct. Let me just comment this. Okay, if okay, so what I'll do is I'll do this tie xy. Okay, tie basically just takes in the x. Okay, actually I can just do it in an easier way. I can just do this person dot first y equals person dot second. Yeah, I could just do this. So maybe over here I just have maybe I just call it n1 x1. Okay, and n1 is person dot first, x1 is person dot second. So person dot second is the amount that he has. Okay, so if okay, so what we'll do is we will take the amount and we minus equals to x. We minus away this x here. If x greater than zero, if x1 greater than zero, if there's still an amount left, then we will need to put it back to the queue. Um, so we will need to people dot push make pair. We need to put this guy back at the queue because he still needs to take some more money. So make pair I n1 and x1. Okay, if still need to withdraw some more, and go to back of queue. Otherwise, we will we will make the person go to the final order. I don't think this is very efficient, but no, let's see how it goes. Yeah. If not, go to back of queue. No, if not, the person is done and put the number in the final order. Okay, so this should do the trick for the code. Okay, not sure why the indent is not indented in the. It's like, yeah, if you do Python, you will understand why I'm not too happy with the indent here like that. Yeah, so let's just try to code this out. Okay, run my code. Okay, this auto code doesn't matter because auto is still working. My C++ is not a very recent extension, but the auto method still works, so it's fine. So 2 3 3 2 7 4. I'm supposed to get 1 3 2. So over here I get 1 minus 2 minus 2. Okay, which is because I put x2, I should push back n1 instead. So let's try running the code again. Okay, so I should have 2 3 3 2 7 4 1 3 2. That's correct. 5 6 9 10 4 7 2 3 5 1 2 4. Okay, this is correct already. Let's just copy and paste this entire thing. Okay, and then we just put SC++, and we just submit attempt and hope for the best. I'm not sure whether this naive attempt is enough to get past Google's judge, because not look at the case, the test case here is very very big. So a simple naive method of doing a queue like this may not be enough to solve this problem. There might be a trick that we need to employ in order to solve this, yeah, in order to solve this queue question. So we'll just take a look at what they tell me. Okay, so pending judgment means it's still like waiting for the judge to decide whether the code is it efficient or not. So I don't think it's efficient for test set 2. Maybe for test set 1 is okay. Yeah, because the numbers are very small. But test set 2, the numbers are very big. Like if you have 10 to the power of 5 and then you do 10 to the power of 9 times, that's not enough. So another way I thought of is, instead of doing this while here, I can simply just take the, the number divided by x, and then the mod. Okay, so we can actually um, we can sort of like group, we can sort of sort the people. Yeah, we can actually sort them in terms of extending, in terms of extend. No, actually I can't really sort also. Probably need to divide them. I don't think I will pass the second case. Yeah, this this first problem surprisingly difficult. Let's just see how many people solve this. Yeah, so 26 solved the first test set, 57% solved all two. Seems like this you see this guy, he solved in 3 minutes. Looks like there's no real what do you call that, real trick over here. Maybe they really wanted to test how you can use the queue. Okay, time limit exceeded. So it is because of this wow here. Um, I'll need to think of a more efficient way to like make the person go back to the start again. So maybe I can do a blanket instead of doing a queue like this. I can do a blanket subtraction to make it, to make everything -5 or minus x to everybody, and then I see whether the person has. Hmm. Or I should just take whoever that doesn't need top up. Okay, there must be some trick to do this. So maybe instead of doing the amount here like that, yeah, there should be some linear way to like sort the things. So okay, so I have n, right? Okay, so let's say I have a few people like that. This guy need $10, $20, $30, $40, $50. I mean, maybe we can just vary up the numbers like that. Let's say we have this group of people that need this amount of money. Okay, uh, I'm pretty sure I can sort this thing in linear time without doing any queues at all. So you know what? Let's just scratch this entire thing. Okay, let's just okay. This one's still okay. Let's scratch this entire thing. I don't think I will need to use a queue at all because the queue is a bit too slow for this problem. I believe I can do a sorting algorithm in O n log n time, and then this will solve the problem already. So okay, let's think about it. If let's say the withdrawal amount is 10, so this guy straight away will get his money already. So this guy will need zero repetitions, and then the modulo is zero. Okay, so okay, not modulo. The order is zero. So this guy is 0 0. Okay, the second guy, he needs to repeat it two times. Okay, so the second guy will be two, and then his order in the queue is one. So this guy will be like that. This guy will repeat it two times because he needs to. Actually, he need to repeat it three times. Yeah, because 22, you draw $10 out, you still have $12 left. You draw another $10 out, you have $2 left. Then you'll be in the queue three times. But with all in all purposes, I mean because this will be he needs to go one time, right? So I need to take the ceiling of of the number of times they need to go in the queue. So this one he need to go in the queue four times, and his order number two. Okay, so maybe over here I'll do a like 21 here. So this one needs to go three times, and he's number three in the queue, and this one need to go through six times, and he's number four in the queue. So I need to take this one times n, three times n. Yeah, so that because there's n people, I want to make this like bigger than the total number of times that I can like sort this entire thing. Yeah, I should be able to sort by the first index of the yeah. I should be able to sort this by the first index. Sort pair by first index. If I'm not wrong, you don't even need to do anything. You can just do the sorting. We will sort like that. Yeah, we can just do a sort, and then it should sort finish already. Okay, so let's implement the ideas inside here. So so we do just need one vector. Okay, so the vector will be consisting of a pair with an index and a and output. So it's a pair long. Okay, so push dot make pair. Okay, so I want the ceiling function in C++. If I'm not wrong, it's called math.ceil. Let's just double check what it is. It's just called ceil, CEIL. So ceil is we just need ceil. Okay, so over here we just do a final order push make pair. Okay, this one at the beginning it will just be amount divided by. Actually, I just realized something. If I just do a simple division like that, uh, yeah, I'll need to take the ceiling. Okay, so what what I was thinking of is I can simply just use like amount plus one. This is an idea I have. I just use amount plus one divided by amount plus one means that this kind of people like 10, when they go 10 it will be 11, and the 11 divided by the amount he will get one. Amount minus one, maybe I should do amount minus one instead. mm, Hmm. Or I should just do the high and fast way and just take ceiling. Yeah, maybe I should just do seal. I should do what I did my thought processes on. So over here we have to do the amounts. Okay, I do a 1.0 because I want to make it a floating point. If not, if I do a seal like that, okay, amount divided by x. Yeah, so this will tell me like how many times this person has needs to withdraw from the ATM. Okay, and then we need to take this times n. Okay, and then we need to plus the order of the index plus I. Okay, and over here will be the index like that. So at the end, let's just we need to sort final order dot begin final order dot end. Yeah, I'm not sure whether this will work, but I do know that our original method of using a queue is too slow for the compiler. So okay, there's some errors here in my code. Okay, let's see the warning. I don't care. I just want to see the error. Error: no member called push in. It's actually push back now. Instead of push, push was a vector. Push was for queues. Pushback is for vectors. Okay, let's try again. Yeah, I mean, if you don't really know programming, this looks kind of messy, but it's perfectly normal for programming. Error: invalid operands to binary operation. Okay, so this one actually should be, we should just print out the second person. So this is a pointer that points to the second, which is the second element of my pair, which is I. Okay, let's try this again. Warning. Okay, warning is fine. Warning is not an error. So yeah, let's try running this code. Okay, so now it prints out 0, 2, 1, which is actually correct. 2, 4, 0, 1, 3. So actually this approach kind of works. I just need to change this to I plus 1. Okay, and this should work already. Because the index starts with 1. Over here I is 0. That's why 1, 3, 2, 3, 5, 1, 2, 4. Okay, looks good. I try submitting this code again to the judge, and hopefully this attempt will pass. Yeah. So yeah, Google Kickstart is like that. We need to just keep trying, and hopefully we'll solve the. All right. Yes. Yes. I'm good. I'm good. Yes. All right. So indeed, it's just doing this. We just take the number of times it will go through the ATM, and then we multiply it by the number of by n, and this means that we will actually like compensate. So if let's say he needs to go multiple times to the ATM, we need to times n again to like cater for his position at the back of the queue again. So we like we simulate the going to the queue at the back. We keep simulating this using a number. So instead of doing a while loop, which can potentially take 10 to the power of 9 times, uh, o 10 to the power of 9, uh, instead of doing that, we can simply just use a division and take the ceiling of it. So this will tell us the number of positions behind the queue he will be at. Then we can sort based on this top number. We can sort for all of the people. Yeah. So this approach works. Okay, and then by sorting we can run it in O n log n time because the sort algorithm is n log n using quick sort. Yeah. Over here, we let's see the analysis of this problem. So ki is the number of times the person will use the ATM. Very good. Google, I think like you. All right, that's great. Sealing of this, very good. Okay, we can dynamically simulate the process using a queue, exactly what we did earlier. But the worst time case complexity is okay. This n times 100 because ai is 100. But with ki as big as 10 to the power of 9, simulation is too slow. So yeah, normally in this kind of Google Kickstart problems, if you can simulate the whole problem out, it's probably a trap. Yeah, that's why I simulated because I thought that since this was the first problem, it shouldn't be that tough. I was wrong. Yeah, they decided to do a tougher first problem, I guess. Yeah, so yeah, so this observation is enough. Sort people in ascending order of ki, then in case of tie, in ascending order of their numbers. So essentially, this is what we are doing here. We sort by ki, which is the number of times they use the ATM, and then we just multiply by n to just make sure that this number dominates the second one. Okay, and then after that, if there's a tie in this, then we go by the number. So by sorting it in this order like uh, this quick sort order preserves the order of the elements that you put it inside. Hence, the complexity of this solution is O n log n. I'm impressed. Okay, I solved it. Okay, let's see. Oh, this round F is kind of tough. Look at that metal harvest. I wonder if I can like solve this. I only have 15 minutes left. Yeah, maybe I should just end my stream here and solve it another day. Yeah, because I do have to have my dinner soon. Well, let's just try to solve it. Okay, we just try. Okay, let's duplicate this. I love solving this kind of programming problems. Yeah, it's an exercise for the mind. Yeah, well played. Oh, thanks. Yeah. So so as always, the only thing that if you have this template code for Google Kickstart, the only thing you need to modify is the solve function. The rest, you can just okay. Let's just put the space here because I deleted it just now. The rest you can just keep it there. So this saves some time in Google Kickstart. So like I did the recent round D recently for Kickstart. I solved three problems. Okay, actually it's one problem and two half problems out of four problems. Yeah, so I need to improve a bit. Yeah, so my rank was like 2,000 out of 200,000 people who took part. Yeah, so next time around I try to make it within top 1,000. To do that, I think I need to solve three full problems. Yeah, then when my programming becomes better, I try to solve everything. Yeah, then you can be top 100 if you solve everything. Yeah, which is quite kind of difficult because their last question is a killer question. Yeah, Kickstart last problem is always very hard. But just 3 months back, yeah, I wouldn't say 3 months, just 6 months back when I did my first Google Kickstart, I solved zero problems. Yeah, so I think I've come a long way from solving zero problems to solving like two to three out of four. So yeah, you just need to keep practicing it. All right, let's see the problem right now. You are in charge of deploying robots to harvest Kikim from a nearby asteroid. Robots are not designed to work as a team, so only one robot can harvest at any point of time. A single robot can be deployed for up to k units of time in a row before it returns for calibration. Harvesting can only be done during specific time intervals, blah blah, given k and time intervals in which was the minimum number of robot deployments required to harvest. Okay, so k units of time before it returns for calibration, regardless of how much time it spends on harvesting. Okay, time intervals. So this is an optimization problem where you need to optimize time intervals. So first line gives two separated integers n and k. Okay, let's see n and k is what? N, k. So it looks like quite big, so it's a long. Okay. So first line takes in two numbers. I always like to do the input output first. It's kind of brainless. Yeah. N and k. The next n line contains a pair of. So next n lines will be like that. I equals 0, I smaller than n, I plus plus. The next n lines contain a pair of space separated integers s and e, the start time and the end time of the ith intervals. Okay, so this will be like 2, 3, 5 will contain three lines, 1, 2, 3 of the intervals. Okay, So maybe in this interval, we need a structure to store it. So maybe we store it as a pair, okay, and we store it as a vector, okay, a vector of this pairs, and we call it robots, okay, robots. Yeah. So we still need to take in S and E. So we take in S and E, and then we store in this vector robots. Robots dot pushback, and then we make pair. We make this pair S E, like that. So this is good for the input output. Okay, so now let's think about how to solve this problem. Okay, each test case output one line containing x, y, where y is the number of times robot deployment is needed, so that for each interval there's one robot harvesting at that time. Okay, let's see this sample case 1. We deploy robot at time instant 1 and it becomes available for the interval 1, 6. However, it only harvests for, okay, so k is the time interval to, what is k? Up to k units of time in a row, okay? But what's S and E? S and E is start and end. Okay, S and E is start and end of the robot. So interval of Si equals 2, Ei equals 5 has duration of 3 time units. Okay, harvest only 1 to 5. Then we deploy the robot at 6 and it becomes available for the time interval 6, 11. Okay, so this robot can do from 1 to 5 and 6, 11, covering both remaining intervals 8, 9, 10, 11. So 8, 9, 10, 11. Can deploy the second robot at 7, which will then cover the range 7, 12. That's harvesting for the intervals 8, 9, 10, 11. Okay, so in case 2, we deploy a robot at instant 1, available for 1, 3, because it's only available for 2. Okay, so I guess these are the intervals that um, you want your robot to cover. Yeah. Actually, we can do it greedily, isn't it? Yeah, as soon as we don't have a robot deployed, then because all these time intervals are kind of fixed, yeah, and it's only up to 10 to the power of 9. I think I can have an array with 10 to the power of 9 elements in it. Yeah, these are the intervals that we need to harvest. Note that intervals don't include the time unit starting at the moment E. Okay, so that means 2, 3, 4 only for this. Like example, interval S. I have a feeling it's a greedy method to solve this. Like you solve it greedily by just deploying a robot right at the start, the first interval possible, and then just deploy as long as the robot needs, before it needs to come back. Then you see the next interval that is present, and then you deploy for that interval all the way, and so on. Yeah. So you see, if you go to 7, 12, you can go cover 8, 9, and 10, 11. I don't get this. Please note that intervals don't include the time unit starting from the moment EI. So an interval with SI equals 2, EI equals 5 has duration of 3 time units. It's kind of weird. Yeah. Why? Why don't you include starting at E? I mean, you see, if you deploy a robot from 1 to 6, that's 5 time units, right? I mean, I don't really know how the robot is deployed, but it looks like, between 1 and 3, it can cover like 1, 2, and 2, 3. Yeah, I guess the interval is not the start and the end. It's like more like the what do you call this? The segment length. So if it starts at 1 and it ends at 3, the segment length is 2, and over here the segment length is 1. So for all purposes of this question, as long as my start number and my end number of the robot deployment falls within this segment here, I will cover the entire segment fully. Yeah. So what I'm thinking of doing is actually something very, very straightforward. I will just need to look through this entire thing 10 to the power of 9 times. You see over here, this test case is 100, 100, 200. I can solve this pretty easily. I can just create a vector with 200 inputs, and then I just sort my start and end. I can just label the vector as 1 if the start and end is inside this robot's vector. Okay, and if not, then that basically when I deploy my robot, I will just skip all the time intervals possible. Yeah, so it is a greedy solution. You go from left to right. The first time you see that there's a 1 in the vector, you deploy a robot for that k duration, and then you repeat all the way. The only problem is for this one. This is a 10 to the power of 9. I'm not too sure whether I can do a vector with size 10 to the power of 9. But you know what? Let's just do the vector way. I mean, if you were to store this in this kind of dictionary like this, it's possible also. Sorry, in this kind of vector like that with a pair like that, it's possible. We just need to sort the pairs by the starting duration. Okay, so that when when the robot comes back, if let's say it did not cover fully this entire duration, then I will need to like push back the remainder inside this. Uh, it's a little tougher if I were to do it that way. Let's just try the easier way. Okay, we just instead of a vector pair, which I think will be needed for the actual solution. Yeah, let's just try a solution to just solve test set 1. Okay, so we first define a robot's vector that is of length 200, and then we just fill up all of them with 0. Okay, over here for long j equals 0, j below. So I'm only trying to solve the first test case. Yeah, so um, j is smaller than. Okay, this actually should be 201 because 200 is the last input. For j equals 0, it's a bit dark. Let me just on the lights. For j equals to 0, j is smaller than. Okay, j equals s, j is smaller equals to e. Okay, so the interval does not include. Don't include the time starting at the moment e. So 2, 3, 4. The e is not there. So just j smaller e, j plus plus. Okay, robots. Okay, robots j equals to 1. Okay, so we don't do this pushback anymore. So then we just look through this. So we do have a long here. Counts equals 0. So for long I equals 0, I smaller than n, I plus plus. Okay. If robots I is 1, okay, then what we'll do is we'll just do count plus equals to the count will add the k. So k is my counts. So I can just deploy the robot for that k intervals, cover everything. Okay. So count plus plus actually count at 1, and then I plus equals to k. So my I can straight away go jump k intervals long. Instead of considering interval 0, I can straight away start it at I can straight away start this at. Okay, so actually this is wrong. This should be 1 smaller equals to n, because n is the, what's my n again? N is the, oh, actually it's not loop to n. This should be loop to 200. Yeah, I mean we just take the worst case. So we look to do, so this one is look for entire robot segment. Deploy robot only he when he encounters a one. Okay, so we do this. We then increase the segment by k to denote, like over here. Let's say over here by k. So if let's say at one it encounters the segment one, it straight away jumps to six. Okay, and then at six, then it checks again whether there will be anything. So if let's say it's a zero, then we just continue this. So at the end, we just need to see out counts. Yeah, I think this should solve test set one. Error unidentified n. So it's a big N instead of a small n. I think I can solve test set two, but I don't think I have the time to solve it. Maybe I'll continue this stream on another time. Yeah, to solve the next few problems of round F. Yeah, yeah. Because if I were to use the normal method, so it's 2 and 3, so it looks correct. Let's just copy and paste this code, switch to editor. Okay, paste paste my code here. Okay, submit. So this is to just solve the earlier attempt. I'm just giving up on this 10 to the power of 9 because a loop of 10 to the power of 9 long like this will not, yeah, basically we can't do it. We can't do a 10 to the power of 9 loop. It will exceed the time limit. Yeah, so samples pass, test set one wrong answer. Okay, I even got the wrong answer for the first test case. Yeah, it passes this field. Okay, so I'm not too sure why it got a wrong answer. Okay, so I equals to 1. No, unless this is supposed to be an equal. Let's just try. I mean, it solves the test case, but it's not solving all the answers. So there must be something wrong with the code here. Yeah, let's just try to figure out what's wrong with the code. Yeah, looks like this approach doesn't really work. All right, let's see the answer. Okay, let's sort the time interval by start time. Yeah, I was thinking of that also. Not optimal to deploy robot before S1 because we'll be wasting. Yeah, so it's S1 plus S1 plus K. So essentially what I did here. Define length of ith interval as interval length EI minus SI. Interval length greater than K. As soon as robot finishes, we need to deploy another one to cover the remainder of interval. If interval length smaller equals K, then we can bring the first robot back as soon as the first interval finishes. We cannot redeploy this robot since a robot can only harvest for consecutive units of time. Okay, allow the first robot to be available until k units of time has elapsed. This is a better strategy since it allows us to, okay, so deploy the robot at the beginning of the first harvesting interval of k hours. If after k hours robot is inside, then deploy another robot to replace it. Otherwise, deploy another robot as soon as the next harvesting cycle repeats. This like sounds like what I did though. There's no robot currently deployed for harvesting. Can deploy robot, keep it harvesting for k units of time. A robot is already currently deployed. No action is needed. Okay. This is difficult. This test case. I'm just curious why it didn't solve my test case one. I mean, this looks like perfectly legit code to solve the test case one to me. Yeah. Unless I read the problem wrongly. Yeah. Only one robot can harvest at any one time. a robot can be deployed for this. What's the minimum number of robot deployments? Looks correct to me. Yeah. So the moment we have a time case of one, I think I got it. Yeah, so this is really like that. So my robot from interval one six, right? So one, two, three, four, five. But actually six is not included in this interval. So actually this should be k minus one. Yeah, I did the question wrongly. I counted the last interval. So if I were to do this, two, three, this will still pass the test case. The test case is not very good. It's too simplistic. So that's why my one passed the samples, but it did not pass the first test case. So I believe if I modify the problem like that, I don't count the end time frame. So that was the thing that I was concerned about. I didn't understand this, but now I do. It means that if let's say it is deployed from two to five, it's deployed only at time points two, three, and four. So five is not included. So similarly, if you deploy a robot from one six, right, you are deploying your robot from seconds number one, two, three, four, and five. Six is not included. That's why you can redeploy again at six. Runtime error. Okay, so it means that I solved the first question, which is what I expected. Yeah, so this code solved the first question, and exactly as what was said here, I did the same thing. So the moment it encounters the uh, a time window it needs to harvest, and if there's no robot there, then we have to deploy a robot. Then we can add one to the robot count. Okay, but for test set 2, because there's 10 to the power of 9, it is not possible to just do 10. You cannot loop O 10 to the power of 9 times. It will firstly exceed the memory limit. Secondly, it also will exceed the time limit. So for test set 2, we need to do it in a different way. Let's see how they did it here. We need to deploy a robot. Okay, so instead of counting the each point of time, okay, we need to calculate the robot needed for an interval is, oh, nice. Yeah, the ceiling of the interval length divided by k. Then you can count the total number of robots needed for the interval itself. So it is possible that last robot deployed will go beyond E1. Yeah, so uh, instead of iterating over the robots like that, we iterate over a robot interval array. Okay, I think I can code this. This is I got the answer in my head already for this test set 2. Yeah, so maybe at about 9 p.m. later, yeah, I'll try to solve this question again. Yeah, if I have some time. Yeah, this I'm quite sure I can solve this problem. Yeah. Okay, but I've got to go. And thank you so much for watching my stream. And yeah, I hope to see you all soon. Okay, see ya.